Bismillahirrahmanirrahim. Now we talk about cumulative distribution function, CDF. A cumulative frequency distribution is the sum of the values in a frequency distribution. All that means is you are adding up a value and all the values that came before it. The cumulative distribution function CDF gives you the cumulative probability associated with a function. It is a similar concept to a cumulative frequency table. So, for example, here you can see that how do we get this cumulative frequency over here. Here the frequency is 2, here the frequency is 3, but cumulative frequency over here is 5 because 3 plus 2 is 5. And here the frequency is 4, but cumulative frequency is 9. 4 plus 5 is equal to 9, 1 plus 9 is equal to 10, 3 plus 10 is equal to 13, and so forth. So that's how we get this cumulative frequency. You can use the CDF to figure out probabilities above a certain value, below a certain value, or between two values. For example, if you had a CDF that showed weights of cats, you can use it to figure out the probability of a cat weighing more than 11 pounds, the probability of cat weighing less than 11 pounds, the probability of a cat weighing between 11 and 15 pounds. Or in case of these scores over here, because this example is the same as this one over here, in which we have talked in the last video about the score of a batsman, and this is the frequency of the runs. So if we want to know the probability of scoring more than 2 runs or less than 3 runs, or score between 2 and 4, so that we can get using this CDF. So this is the advantage of cumulative distribution function. There are certain properties of for discrete random variable. For any discrete random variable x with range from x1 to x2, x1 must be less than or equal to x2 and so forth. It means it must be in the ascending order, and the values must be between 0 and 1, and the CDF never decreases as it goes from left to right, or as you can see over here, this is increasing because of course we are every time we are adding up some value in the previous one. So it can be either the same as the previous one, or it can increase but it cannot decrease. And for a discrete random variable x, there is a jump at each value, and the height of the jump is probability of x. So here you can see that this is x1, x2, x3, and for example the value of at x1 is this, and the value of x2 is this. So there is a jump from this value to this value, and this jump is equal to the probability of x2. And between the jumps, the graph of the CDF of the discrete random variable x is a horizontal line. This is also clear from this figure. You can see that whatever the value is x1, it remains the same until at x2, when it jumps from this value to this value. So here at x2 the value jumps from the value with whatever the previous value was from at x1. And the difference between the CDF evaluated at 2 points is the probability that the random variable takes on a value between these 2 points. So f of xb minus f of x is simply the probability of x between the values a and b. It should be the value of x should be less than or equal to b and should be greater than a. Now, probability mass function of a Bernoulli random variable is very simple. It is just 1 minus p for x is equal to 0 and p x is equal to 1. Otherwise, it is 0. And we know that the probability must be between 0 and 1. Binomial random for binomial random variable, we know that we have seen this binomial random variable function before, and it is the same as before. There is nothing new in it, so we know that it is n choose k pk 1 minus pk n minus k. And what is negative binomial or Pascal random variable? The negative binomial or Pascal distribution is a generalization of the geometric distribution. In the last video we have seen what is not last video, maybe a couple of videos before, what is geometric distribution. It relates to the random experiment of a repeated independent trials until observing k successes. So we keep repeating the trial again and again until we get the event where we are looking for, or the success we get. So x is a Pascal k comma p random variable. If the PMF of x has the form, this is the generalized form for negative binomial or Pascal random variable. This is the equation used for this one. Then we have discrete uniform random variable, and for discrete random variable we use p of x is equal to 1 over L minus k plus 1, where x is equal to k and k and k plus 1, k plus 2 up to L. X is uniformly distributed between k and L. So for example, for a roll of a fair die is an example of uniform distribution. The random variable n is the number of spots that appears on a side of a facing up. Therefore, n is a discrete uniform 1, 6, because the number of numbers can be from 1 to 6 on a die. So random variable where k is equal to 1 and L is equal to 6. And in that case, p of n is equal to 1 divided by 6 minus 1 plus 1 is equal to 1 by 6. So we know that the probability for each number is 1 by 6. So for n is equal to 1, it is 1 by 6. For 2 is equal to 1 by 6. For all, it remains the same, 1 by 6. Poisson random variable. The probability model of a Poisson random variable describes phenomena that occurs randomly in time. While the time of each occurrence is completely random, there is a known average number of occurrences per unit time. The Poisson model is widely used in many fields. For example, the arrival of information request at a World Wide Web, means at any server or at any communication node. The initiation of telephone calls, the emission of particles from a radioactive source. These are often modeled as Poisson random variables. So for Poisson random variable, x is a Poisson random variable if the PMF of x has the form. If it has got this form, then it is Poisson random variable. And here the equation is very simple. A is power x, e is alpha is power x, e minus is power minus alpha, where x is equal to 0, 1, 2, 3, 4. So for example, the number of hits at a website in any time interval is a Poisson random variable. Suppose a particular site has on average 2 hits per second, so the arrival rate is lambda is equal to 2. What is the probability that there are no hits in an interval of 0.25 seconds what is the probability that there are no more than 2 hits in an interval of 1 second. So in an interval of 0.25 seconds, the number of hits h is a Poisson random variable with alpha is equal to lambda into t. Alpha is equal to the arrival rate multiplied by time. So the arrival rate is 2 hits per second, as it is given over here. On average there are 2 hits, and what is the probability that there are no hits in an interval of 0.25. so here we just multiplied by this interval. The number of hits, arrival rate multiplied by number of hits, is equal to 0.5 hits. So the PMF of hits, or h, is equal to 0.5. We just plugged in this value alpha over here, 0.5 this to power h e minus 0.5 h, where h is 0, 1, 2, 3, 4. So to know the probability of having no hit, or 1 hit, or 2 hit, or 3 hits, you can just place the input the values over here and you will get the PMF. So the probability of no hits or 0 hits is equal to 0.6065. It shows that the probability of 0 web server hit is very high in a quarter of a second. So probability that there are no more than 2 hits in 1 second. In this case, this time interval has changed over here. So we just multiply the arrival rate with the time, which is now is equal to 2 hits. In this case, the PMF is equal to P of h is equal to 2h e raised power minus 2 divided by h factorial. So we are asked that what is the probability that there are no more than 2, not more than 2 hits in an interval. So in that case, our h becomes less than equal to 2, which means that we have to find the probability of h at 0, 1, and 2. So the probability of having no hits is 0.1353, having 1 hit is equal to 0.2706, and having 2 hits is equal to 0.2706. So we just simply add up all these probabilities to get 0.6765. So the probability that there are no more than 2 hits in 1 second is 0.6765. There is another example. The number of database queries processed by a computer in any 10-second interval is a Poisson random variable k with alpha is equal to 5. Here the arrival rate is already given. Alpha is equal to 5 queries. What is the probability that there will be no queries processed in a 10-second interval? What is the probability that at least 2 queries will be processed in a 2-second interval? So it is very simple over here. We are this alpha is already given, unlike the previous example where we had to calculate alpha. Here the alpha is already given, so we just place in the values of alpha over here and we get this PMF equation. Now to get the PMF, we simply plug in the value of h. So in the first one, it is asking what is the probability that there will be no queries. In that case, the h is equal to 0. So in that case, the probability is 0.0067. Probability is very low. When the arrival rate is very high, 5, then if you expect that you will have no query at all in 10 seconds interval is very low, 0.0067. To find the probability that at least 2 queries will be processed in 2 seconds interval, first find the lambda for 2-second interval. Here, since the time interval has changed, because this alpha is given for 10 seconds, but here we have to they are asking for the probability of queries in 2 seconds. So of course the alpha will not be the same. So how do we get this alpha? We simply say 5 is equal to lambda multiplied by 10. So 5 is the given value, we multiply by lambda what we have to calculate and arrival rate and multiply by 10. So lambda is equal to 5 divided by 10 is equal to 0.5. So in this case alpha is equal to 0.5 multiplied by 2 is equal to 1. So putting this value of alpha over here, and to find the p of h greater than or equal to 2, because that's what it says. It's asking that what is the probability that at least 2 carries. Again, that it at least means it is greater than or equal to 2. First we have to find we will find probability of h less than 2 and then subtract it from 1, because greater than 2 goes up to infinity. I mean, we cannot calculate all the values, so we simply subtract it from 1, because we know that the maximum probability cannot be more than 1. So first we find probability of h less than 2, which is p of h 0 and ph of 1, where we get no hit is 0.367 and 1 hit is equal to 0.367, and we just add them up to get 0.374 and we subtract it from 1, so it gives us 0.266. So the probability that at least 2 carries will be processed in 2 seconds is 0.266.